I am Satyam here from Codezilla. So today we'll be going to solve few of our problems. These are algorithms which we'll be solving today. We'll be understanding how it works, and these are the things which might ask in the interview, and we have to explain those things to the interviewer, and then we have to code too. So we will be learning the whole step one by one. So let's get started quickly. So today we'll be, as I have told you earlier on, like we will be doing uh, sorting algorithms. But at first we will be starting off with the selection sort, because we can say the starting point of doing any of the sorting algorithms. So now let's get started. So in sorting algorithm, uh, selection sort is at first. But if I have to tell you brief about the sorting, then what happens is like in CPP, uh, if we have an vector of int, and I will name it as ARR. So this is a vector int ARR. It means it is an array, dynamic array, we can say, in which will be having some int value in it. Now, how sort things, how to sort things is, there is a pre-built function which we generally use. Like we can just write sort, and we have to write ARR dot begin and ARR dot end. Although what happens whenever we will be solving any of the problems which are at bigger level, like if we are solving any of the question, let's suppose in lead code or in any of the compiler, or just solving it by our own only, then we are supposed to use this sorting algorithm only, because we didn't need to write that much code for sorting it off and on. These are inbuilt. But if an interview directly asks you what is selection sort, explain it and then code it. Insertion sort, bubble sort, merge sort, quick sort. So they are like prominent five algorithms which you have to learn. So now let's get started with the selection sort. So from the name only, like selection sort, we will be getting two things in mind. The first thing which should tweak in our mind is selection sort means we have to select and then sort it. So select and sort. So how can we think of selecting an element and placing it in incorrect order? So how we can do is selection sort as in first instance we will be doing it in uh, like non-decreasing order. So non-decreasing means ascending. We will be starting from the smallest and then going to the largest at the end. So if you have to place smallest at the beginning of uh, our array, and then the largest at the ending, then what we can do is we can place elements one by one from the start by finding any element which is minimum in the remaining one of them. How we can do it? Let me show you with an example only. So here you can see that if there is smallest written here. So if there are some number, there is a number which is here. Let's suppose that number is x. So what we will be doing is we will be iterating in this whole array and finding the number, minimum number in this whole array. Now, whatever number we will be getting, we will be swapping it with the first element, which is x, with the minimum number which we found. So now what will happen? The minimum number in that whole array is now here. Now what we have to do is we have to go to position y. Now for y, we have to select the minimum element from starting from this y till the end, not including the first one, because we have already got the minimum. If we take that also, then what will happen? That minimum element will be same like on first and second b, and we didn't have to repeat it in a way. So we have to find the minimum, which is next minimum element, we can say, in that. So now what we will be doing, we will be taking this y, and we will be again finding a minimum in this array, and whatever minimum we get, we will then again swap it off, swap it with y and min. Now in this way we will be iterating in this whole array one by one, and we will be finding the minimum array, swap it with the beginning and increase the pointer, swap it, increase, swap it, increase, swap, increase, swap. So in this way, what will be happening? We will be iterating in the whole array, minimum will be getting, we will be sorting it one by one. Now, what will happen in this algo specifically? Like in this algo, like we can say it is uh, finding minimum, finding minimums, and then swapping it. So this is the brief and this is the core concept of a selection sort. If we have to explain, just say it. We will find the minimum and swap it with the minimum. Now let's code it and then try to understand like how will it work. So I will be going in any of the online CPP compilers, which might they also ask like to open any of the CPP compilers. Firstly, we have to set the environment for our coding. So I will be doing this. I will be doing include and I will be including with slash stdc plus plus dot h and using name space std. Okay, so this is the brief about the environment which you have to set. We have to write it in the main function. So what I will be doing is I will be doing int and I will be declaring it and I will be taking it as an input. This will be the size of the array which we want to have. Now we can take int arr or and then we can declare size of this. Let's suppose it and x of n size, and then we can use a for loop from int I equals to 0 from I less than n and then I plus plus, and then at the end we will be doing sin of arr. So it will in this way we will be taking an input of an array. It is an just a simple syntax to find an input of an array. When we initialize it with the n size, it will be having garbage values because it is in main function. So after that we push the values one by one in this. Now let's get started with the main thing, which is like doing selection sort. And what are the things which we will be giving to it is first thing will be the array which we will be getting, and second one is the size which we will be having. And along with that, I will be making it a void function, and because of that, the changes should be happening here only. And to get the input, like here, what I will be doing, this is the syntax in which we can directly print the values of that ARR. So I will be doing this cout x and then giving a space. Now it's done. Now let's go to the algorithm which we have to work on. I will also recommend you to code the functions outside. Like if there is any specific functionality which you will be implementing, then implement it outside your main function because it will be reusable then. So now firstly let's int arr. Second thing which we have to do is that will be the size. Now let's implement the sorting algorithm. As I have told you earlier only, there will be one pointer which will be starting from the beginning, and we have to start finding the number from there only. So I will be doing it this uh, and this and then. So it will be starting from the beginning and going till the end. This will be the brief of selection sort, the first row we can say. Then we have to make another one, or either what we can do is we can also make it as int mini, take an mini, and which will be initialized with the value of I only. Let me change it. Yeah. So what we'll be assuming is we are assuming the first element of it as the minimum element. Now we will be making another for loop from int I equals to j. Sorry, j equals to I, and j will be lesser than same size of the n. J will also getting plus plus. So now what will be happening is it will be j will be at first index only. It will be iterating in the whole array and finding the minimum and updating it, and then we will be swapping. This is the thing which we have to finally do. So what we will be doing is we will be firstly finding the minimum. If any of the element which is in J becomes less than the minimum, then minimum element will be our minimum element which we will be having is ARR of J. Just a simple process to find the minimum element. Now we will be having the minimum element which we want to have. Now the process is of swapping it off. Now whenever we find it, we will be taking it in this way, and then we will be performing a swap operation in which we will be swapping ARR of I with the ARR of J. So whenever we will be finding any of the minimum element, we will be swapping it off, and then just after that we have to just return back. Like there is one for loop, there is another for loop if condition, and after all of these, we will be just doing return because we have made it as an void. Uh, so now what we can do is this whole is done. Along with that, we can also you also have to keep one thing in mind. This is an initialization of an array, we can say. But in any of the like online compilers or online platform where you have to solve it, there one thing will happen for sure. You might not get the ARR there. What will happen, you might get a vector of so you have to think of like doing it with vector. So here it is done with int. Let's do it with the vector instead, so that we can actually get all the stuff. So for doing it with vector, there is nothing like more we have to do is we have to just make it as an ARR and just initializing the value of it, and that's all. Like we are sending this, and we have to change just this thing which will now become vector, and make, make it int, and ARR. Yeah, so why I wrote this ARR, so that it will be passed as in reference. So now I think we are done with it. We have implemented everything. Now we can run this program and see if it works or not. If it doesn't work, then we will be finding any of the other ways or the error which will be coming. So now let's get started. Now we will be giving an input of 5. First number I will be giving as 2. Let's give 16 as second. Let's give 45 as third. Let's give 3 as this, and yeah. So here you can see that it got sorted in the correct order. Like I have given 2 in the beginning, 16, 45, 3 and 1. But when it gave me the output, it was in a like sorted order, 1, 2, 3 and 6 and 45. So in this way, this program works perfectly fine, the selection sort one. And that's all what we have to do in an interview too. Now let's understand the time and space complexity which we will be dealing of. Because in an interview or if in any of the online compiler, if they will be telling you, then you will be getting this function only to write off, not this one. So you didn't have to think about this thing. This is just like we can say a functional build of it. Now let's understand the time and space complexities. So now what will be happening is uh, here you can see that we will be using a constant space. So firstly talking about the space complexity only. The space complexity will be a constant, as we are not using any of the array or any of the additional thing to work with it. So now let's understand the space complexity here. Here you can see that two nested for loops are here. So if we have to understand the time complexity, so what we will be understanding is there are two for loops. One will be running from uh, 0 to n. So for sure, the time complexity will be big of n for the first one only, but we are two one and both of them are nested. So, but we have to think about the second one. The second follow which we have will be running from we can say it at first instance it will be running from n to 0. Then it will be running from n minus 1 to 0, then it will be n minus 2, n minus 3, and so on. So why this is running from n minus 1 in the second, and n minus 3, n minus 2, so on in the upcoming months, as it is starting its starting point is based on the ith value, like I will be the point from where it will be starting. So if I will be increasing, it will be decreasing its operation by one. So that's why it will be doing it in this way. So we can say that it is, if we have to analyze now, so it will eventually become, we can say, a formula of sum of first and natural numbers till like till 1. So what will be the formula for that is n into n plus 1 by 2. This is the formula for finding the sum of first n natural numbers. So this is the thing which will be happening. Now, if we have to break this down, so it will be becoming n by 2, and uh, like we will be multiplying it, n by 2 plus n divided by 2, and this will be n by 2 by 2 and plus n by 2. Now, as if you have understood the time complexity in the uh, earlier parts, then what what you will be understanding is we have to think about the time complexity in an like a bigger vision. Like we didn't have to think about this two or this n by twos and all the stuff, which are like smaller values as compared to this. So we have to give time complexities in an like big O of something value. So it will be for sure big O of n square. So what this complies is this big O of n square will be for sure in the like is the worst time complexity in the worst case, the better one also, and the most optimal also, because this uh, two for loops which we have done, there is nothing to break out and nothing to be like stopping this to iterate it again. So that's why we can say that big of n square will be the maximum time complexity which is possible in this selection sort algorithm. So that's how we can explain and we can perform a selection sort on an vector or on an array. So that's all for the video. I hope you like it. Thanks for watching.